All right, geometry students, here we have lesson 6.3, and back in 6.2 we recognized and applied properties of parallelograms. Now we're going to recognize the conditions that ensure a quadrilateral is a parallelogram, and also we're going to prove that a set of points forms a parallelogram in the coordinate plane. And here we go. Here are the conditions for the parallelogram. So the parallelogram, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if we have this side congruent to BC, and we have this side over here congruent to AB, notice it says opposite sides of a quadrilateral are congruent, then quadrilateral is a parallelogram. All we have to show is that those lengths are equal. And so then the second property, or theorem, I'm sorry, it says if both angles, opposite angles, are congruent, then a quadrilateral must be a parallelogram. Then also, if the diagonals of a quadrilateral bisect each other, so when AC and DB cross each other, if they make these the same length, and if they make these the same length, then it is a parallelogram. Then finally, if one pair of opposite sides of a quadrilateral is both parallel and congruent, so the parallel sign is right there. So if they're parallel and they're congruent, so if AB is parallel to DC and AB is congruent to DC, then ABCD is a parallelogram. Okay, and here is the theorem, 6.9. Proof of it, if when WX and congruent to ZY, and when WZ is congruent to XY. So that was the first one. Okay, so just take a look at that. We're not going to have to prove it. Okay, but we are going to determine whether the quadrilateral on the next slide is a parallelogram. Pretty straightforward. So here we go. We have 35 and 35 and 20 and 20. So each pair of opposite sides has the same measure. Therefore, they are congruent, and if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, which method would you prove the following quadrilateral is a parallelogram? Okay, go ahead and pause your video and make a choice. Good. If you said one pair of opposite sides are both parallel and congruent, you chose the right answer. Okay, here's a real-world example. Scissor lifts, like the platform lift shown below, or to the right actually, are commonly applied to tools intended to lift heavy items. In the diagram, A is congruent to C. So the the angle A is congruent to the angle C, and angle B is congruent to the angle D. Explain why the consecutive angles will always be supplementary regardless of the height of the platform. Okay, that's kind of a... Okay, well, since both pairs of opposite angles of a quadrilateral are congruent, ABCD is a parallelogram. And theorem 6.5 states that consecutive angles of parallelograms are supplementary. Therefore, measurement A plus measurement B equals 180, and measurement C plus measurement D equals 180. And so, therefore, by substitution, measurement A plus measurement D equals 180, and measurement C plus measurement B equals 180. We can easily see, right? All right. So the diagram, real-world example here, shows a car jack. And we have AD is congruent to BC. Side lengths AD. So we got this side length here, this side length here, and AB and the DC. Based on this information, which statement will be true regardless of the height of the car jack? Good. Pause your video. If you said angle A is congruent to angle C, you are correct. Opposite angles, since the four sides, right? Opposite sides are congruent, then the opposite angles will be congruent because it's a parallelogram. All right, so now next problem we're going to try to find x and y so that the quadrilateral is a parallelogram. That shouldn't be too hard. Okay, we know that 4y minus 2 being one side must be congruent to the opposite side, therefore their measures must be equal. So we have 3y plus 3. I just distributed my 3 through right here. Okay, now I'm going to subtract 3y from both sides and add 2 to both sides. Therefore I got y equals 5. Same thing goes with the x, right? We have 4x minus 1 should equal 3x plus 6. Add 1 to both sides, subtract 3x from both sides. We should have x is equal to 7. So there's my x equals 7. And then finally, we get my y is equal to 5. All right, check your progress. Find m so that the quadrilateral is a parallelogram. Remember, a parallelogram, if the opposite sides are both parallel and congruent, then it's a parallelogram. Go ahead and pause your video. If you said m equals 6, you are correct. They have to be congruent. So therefore, their measurements must be the same. So 4m plus 2 must equal 3m plus 8. Subtract 3m from both sides and subtract 2 from both sides, and we get m equals 6. Okay, here's a concept summary. Prove that a quadrilateral is a parallelogram. Well, we can do that by showing that both pairs of opposite sides are parallel. You might want to take a picture of this. This could be on your test. Show that both pairs of opposite sides are congruent. Or we can show that both pairs of opposite angles are congruent. Or we could show that the diagonals bisect each other. Or we could show that a pair of opposite sides is both parallel and congruent. All right, so now we're going to have parallelograms and coordinate geometry. We're going to determine whether a quadrilateral is a parallelogram. And we're going to do it by justifying by using the slope formula. Okay, so we have this QRST quadrilateral, and we're looking at Q and R and S and T. So QRST. So we have a side QR and so on. Side RS, side ST, and side TQ. Let's look at the slopes. If the opposite sides of a quadrilateral are parallel, then it's a parallelogram. Okay, so we have the slope of QR. That's my first side. And we get negative 1/2. Okay, now we're going to look at the slope of ST. Okay, and that's also negative 1/2. All right, now we're going to look at the slope of RS, which is 4, and the slope of TQ, which is 4. Therefore, since opposite sides have the same slope, then opposite sides are parallel. Therefore, QRST is a parallelogram by definition. All right, now you're going to check your progress. Determine whether the quadrilateral on the next slide is a parallelogram. Go ahead and pause your video. Good. If you answered no, that is correct. The slopes are not the same. Okay, we're going to write a coordinate proof of the following statement. Right? If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay. Step 1. We're going to go right through this, but you won't be responsible for it. Okay? Begin by placing the vertex at A at the origin. So let AB have the length of A units. Then B has coordinates A, 0. So if the distance from D to C is also A units, let the x coordinate of D to B and of C be B plus A. So here's the picture of it. And since AD should be congruent to BC, position the endpoints at DC so that they have the same y coordinate C. All right, so now we're going to use the figure to write our proof. Quadrilateral ABCD, AB is congruent to DC and AD is congruent to BC. ABCD then is a parallelogram. By definition, a quadrilateral is a parallelogram if opposite sides are parallel. Use the slope formula. Slope AD is C over B. Slope of AB is 0. Slope of BC is C over B. So look at that. Go back. C over B and 0, and C over B and 0. Since AB, CD have the same slope, AD and BC have the same slope, AD is parallel to BC, and AB is parallel to CD, therefore it's parallelogram. Which of the following can be used to prove the statement below? If a quadrilateral is a parallelogram, then one pair of opposite sides is both parallel and congruent. Good. If you said answer A, AB is A units, and DC is A units. So that's being that they're going to be congruent. And we have slopes that are the same that are 0.